Good evening. I hope everything went okay in class today and that you were able to get your homework done. Well, the classwork, the questions from the book. We're going to start section 12.2. This is forces of attraction. I'm hoping that the majority of this is familiar to you. We're going to be talking about intramolecular forces, describing those, and then comparing and contrasting those as well. Review vocabulary, polar covalent. So this is a type of bond that forms when electrons are not shared equally. So rather than an ionic where they're sharing the two, each of them brings one, this is where two or more electrons are shared, where two or more electrons are brought by one atom and then shared by the other. New vocabulary, you don't need to put this down right now. You'll get it tomorrow on the PowerPoint in class. Be able to work on it then. Dispersion force, dipole-dipole force, and hydrogen bond. Main idea for this section, which we'll be covering all of 2.2 tonight, intramolecular forces, including dispersion forces, dipole-dipole forces, and hydrogen bonds, determine a substance's state at a given temperature. So we had, just a couple chapters ago, discussed dipole-dipole forces, hydrogen bonds, as well as dispersion forces, okay? So this should not be completely new information to you. Attractive forces between two molecules cause some materials to be solids, some to be liquids, and some to be gases at the same temperature. And remember that whether they're solids, liquids, or gases is going to make the difference between whether the molecules are very close together, whether they're further apart, or whether they have quite a bit of space in between them. Okay, also remember when we were talking about how molecules are put together, when we're discussing ionic, you have one positive side being attracted to a negative side, which is attracted to a positive. And so you have more of this kind of structure, okay? Covalent, they're sharing. So you have these electrons that are out here in space being shared by both. And in metallic, remember that all the electrons are out here in this cloud. And so you have positives across from each other, but they're surrounded by electrons, and so that allows them to stay together very strongly. Dispersion forces are weak forces that result from temporary shifts in the density of electrons and electron clouds. So you have temporary dipoles. Remember, these were van der Waals forces that we talked about, where for a while this is a positive end and this is a negative end, and because of that you can have this attraction. Dipole-dipole forces are attractions between oppositely charged regions of polar molecules, and this is what helps one molecule be attracted to another molecule. Hydrogen bonds are special dipole-dipole attractions, so they're like the ones we discussed in the last slide, and they occur between molecules that contain hydrogen atoms bonded to a small, highly electronegative atom with at least one lone pair of electrons, typically fluorine, oxygen, or nitrogen. And because there's this one lone pair of electrons, we have a bent structure, and that helps form the hydrogen bond. So here, obviously, we have water, okay? And so you have the oxygen, which is going to have a positive force with the two hydrogens. So then this hydrogen can be attracted to this oxygen, and that is the hydrogen bond. Properties of three molecular compounds. This is again in your book, table 12.3. And if you look here at the molecular structure and the molar masses and the boiling points, you will see the difference in these properties. So if you look first at water, okay, water's bent, it has a boiling point of 100 degrees versus methane, okay, CH4. So it has all four of these hydrogens, which are going to make it polar, okay, it's able to pull equally on all directions, it has a much lower boiling point, negative 33.4. So it is actually going to boil very, very low. And ammonia, NH3, okay, it has 3 hydrogens hanging off of it, and its boiling point is negative 164. But their molar masses are all almost identical, 16, 17, and 18. All right, here's a few questions for you. A hydrogen bond is a type of A, dispersion force, B, ionic bond, C, covalent bond, or D, dipole-dipole force. Which of the following molecules can form hydrogen bonds? Carbon dioxide, C2H6, ammonia, or hydrogen gas? Okay, that was it for tonight. Pretty short. Make sure that you are finishing up all your homework, you can work on your vocabulary tomorrow in class. Be good for whoever your sub is, and I will have another video for you tomorrow night.